Hello, everyone. On behalf of the Memmert family, allow me to extend a warm welcome to you. Thank you very much for joining in our 2 days webinar in regard to two systems for the conversion of energy. Before going ahead and giving you more details and information in regard to the Peltier technology and also compressor type technology, let me allow to give you information about the team today. There is Annika with me. She's the one who is in charge of the camera. Then we have Andreas. Andreas, he is from our technical sales team. He will be your chat partner. So if you have some questions, please kindly post your questions next to the area where you can find the information on the presentation. And Andreas will be very glad to give you the answers immediately and also afterwards. And myself, I am Andrea. I will be your speaker today for this very nice, interesting topic. So today we have these two systems, which is cooling with a compressor based on thermodynamics, and also the second type, which is the cooling by Peltier technology. Let's go now ahead with our presentation, which will take approximately 45-50 minutes. So when we talk about this cooling with a compressor, which is based on the thermodynamics, then here there is considered pressure, change in state of aggregation, then temperature and volume of the coolants. If we go on for the second technology, for which you can do the heating and cooling, which is based on Peltier technology, then this refers to the thermoelectricity, and here there is involved temperature, electricity. So compressor technology, that is the energy flow in general in one direction, which means this is for cooling down. If we compare this to the Peltier technology, then here we have an energy flow to be generated in two directions for cooling down and also heating up. Memmert is using both technology in the products. So both of these technologies, they have the area of application. They are used, for example, in the pharmacy and food and beverage, in cosmetic industry, and also in industrial sectors like in electronic fields, testing material. For Memmert, we have these both technologies in our cooled incubators, in our cooling devices, and in our climate chambers. Let's go further and let's have more look in regards to these details in regards to the cooling for climate chambers, for most precisely controlling of the temperature. And let's have a look to these details in regard to Peltier and compressor. So these two technologies are used in climate chambers for heating and cooling. And we have this Peltier technology. Here we are talking about Peltier element. This is also an abbreviation. It's called TEC, thermoelectric cooler. And that means through the application of a TC voltage, supply on one side gets warm and the other one gets cold. And depending then on the polarity of the power supply, you can cool down and you can heat up. If we go for compressor technology, that is actually the traditional technology. Here we are using the compressor, and that means the energy transport is done by using gas, which takes the heat energy and releases it during the condensation process when it becomes liquid. So the compressor increases the pressure of the substance, which is mostly a gas, by reducing the volume of the substance. So we will have more details today in regard to the differences of these two technologies, to see for which applications these technologies are going to be used, and also have more look into the laboratories where we can find these technologies. When we go ahead, let me go first to a historical point and give you some data in regard to the development when we talk about this Peltier technology. In 1821, there was a German physicist. This was called Thomas Seebeck. And this observed that a junction of dissimilar metals produces a deflection on a magnetic needle, which was in this case a compass, when it has been exposed to a temperature gradient. And that means voltage develops in the circuit, and consequently, a thermoelectric device creates a voltage when there's a difference in temperature on each side. Let's have a look to this chart here, and let's have a look to this Seebeck effect called by the name of the founder. So what he realized is that when there was a junction, that means he has these two different metals, then he connects these metals, he put their heat, and then he realized that there was a heat difference. So that means one side got hot, the other one cold. That was by the movement, because the electrons, they like to move. So they moved and they went down. And then when he had here like a resistant, he realized there's a voltage on the resistant. And that was this Seebeck effect, which is also called thermoelectricity. Let's go further. So that means we now already know there is electricity. And then there was in 1834, this was Jean Peltier. And he discovered then, based on this Peltier effect, that if you conversely use a voltage which is applied, then there will be a heat transfer from one side to the other side, which creates a temperature difference. And that means he was the first one to generate cold using electric circuit. So that means that is now the other way around. So what Jean Peltier did, he had then an electricity supplied. And when he used this electricity, there was a movement again. So that means one side gets hot, another one gets cold. So we have a difference in temperature. And that means Jean Peltier was really the first one who developed a cooling system based on this Peltier technology. So that means by this movement of the N and P, which means the electrons, which are negative, and then also the positive ones, which are moving around, there was a direct conversion of temperature differences reaching to this effect. So the first one to generate cold using electric current. The working principle we can now see also here on this drawing. And if we have a look to this one, we can see there is an electrical power supplied. Then it means on one side it gets hot, on the interior it gets cold. And this is like a heat pump principle. And that means if the electricity passes through the modules, the electrons are moving, and this means we can heat up the interior, or we can cool down the interior, which means then the heat is transported to the outside. So this is reversing polarity of the current hot and cold side. So this is how the heating and cooling could be done in both directions, always with the same quantity of energy, which is going to be transported. So working principle, in an electric circuit, a temperature difference is created at the contact points of two differently conducting materials. One side becomes cold and the other one warm. Commercially successful, this application only have been when there was the development of the semiconductors. When semiconductors come into effect, then this system could be used in a more bright and enlarged way. Let's go further. Let's have a look to this Peltier element, which is also called electrothermal converter. This is flat, usually square. It has two plates. There's ceramic plates, and it has these two wires. And between, there is an area of semiconductors, and this is in series alternating between the N-type and the P-type. So we can see here the structure of the Peltier element, and they will be used actually the ceramic covers, because here the thermal expansion coefficient is very low, is actually below 0.1. And the electric current, this flows through the cuboid semiconductors. So Peltier element works like a heat pump. Energy is pumped from the cold to the hot side. Waste heat expelled on the hot side is the result of the electrical energy supplied on the cooling capacity. By reversing the polarity of the current, the hot and cold sides can be reversed. And when direct current flow through the Peltier element, a temperature difference builds up. So that means always by this way that there is a temperature difference. This effect came into consideration, and that means the cold side of the element extracts from the environment and releases it to the opposite side. The semiconductor in general has these two different material, which means it could be a bio-metalloid and silicon germanium. So that means important is that there have been two different materials in metal. The one which has more on the electrons, which is more negative, which means here we have the movement, and on the other side with the positive elements. Let's go further. The Peltier elements and Peltier technology are going to be used for the cooling down, but there is a limitation. So that means the common single stage Peltier elements, they have their physical limits at a temperature difference of around 70 Kelvin between the warm and the cold side at rated power maximum. That's what we also can see on the graphical. So that means here's the maximum current intensity, where the difference from the two temperatures is 70 degrees. There is some exceptions going higher, but in general we say 70 degrees, and that means due to the lost heat increases quadrically with the current intensity, and this depends also this limitation on the heat reflux to the cold side, which is proportional to the thermal conductivity of the material and the temperature difference. Okay, let's go further. To avoid now the overheating of the Peltier element and really to optimize this efficiency to get the greatest possible temperature differences, we are talking about cold and warm temperatures, the waste heat must be removed as efficiently as possible. And this is done by our Memmert products with a demand-controlled internal and external fan. And that is sufficiently dimensioned for the cooling element. So that means here we have the Peltier element. We have this assembling of the Peltier module with a heat sink and a fan motor on both sides of the element. And that means this fan is important to transport the heat and the coolness in the best way. And this is done by a demand-controlled internal, external fan and a sufficiently, as I mentioned, cooling elements. These elements are mounted in our units at the rear in the interior, and we have here the best thermal contact considered. So that means we have our own R&D department, and they have a lot of experience because Memmert is using this technology already for more than 20 years. And so they considered the best way how to fix these Peltier elements in our units to get the fast energy flow, to consider then the best stability for the temperature uniformity. So that is what they considered, which means also we're using here a high quality switch power board, which means we have voltage from 200 up to 230 voltage. Let's go further. This was in regard to Peltier technology. Now let's have a look more to our compressor type. Compressor type is a traditional way of cooling. That means we have here a refrigeration unit which extracts heat from the inside of the unit and releases it to the environment. It's also a heat emission that is done by the condenser. And then the cooling is done by the cooling machine, which is the evaporator for the energy absorption. And in the compressor system, there is heat transport, which is carried out by gas which condenses. So that means we have thermal energy that is required during the transition from the liquid to the gaseous aggregate state. Then there is a refrigerant which circulates through the machine piping system. Let's have now a look to the drawing. So we can see here on the left side, the evaporator, the jolt generator, there is a gas in it. So that means whenever samples are placed in the unit, which has to be cooled down, then here there will be absorbed the heat. Then it means it gets a lower pressure and is going up in the system already. And it means this is already gas. So then we have the expanded gaseous, and this goes to the compressor. In the compressor, there is created a high pressure, compressed gases. This means this is necessary that we get a better cooling later on. Then we have the next step, which is the liquefier, the condenser. So here heat goes already to the environment. And then there is a compressed liquid going back through the throttle element. There it will going to be decompressed again. And then it goes back to the evaporator, which is a jolt generator. So that means this is a cooling circuit, is a cycle. And by this way, you can cool down. So compressor compresses the refrigerant under high pressure. Condenser on the exterior of the unit releases heat to the environment. Refrigerant cools down and changes into liquid state. Pressure is reduced again in the throttle valve, and boiling point drops and process starts again. That is in regards to the compressor technology. Now let's go further to Peltier, and let's also see how this is going to be used in laboratories. So from our side, we are already using this for many time, and we have a lot of experience. We are using this for our constant climate chamber. So here we have the HPP Eco type. This has a temperature range from 0 up to 70 degrees. It can manage 20 degrees below ambient temperature. And there is the use and application, for example, for stability testing, where you constantly operate at a fixed temperature value. So this is used for heating and cooling. No air exchange between the chamber and the environment. Condensation during the cooling process occurs on the heatsink, not somewhere in the chamber. Fans integrated in the Peltier element inside and outside of the chamber. This ensures the rapid transport of energy and optimal temperature distribution. And the new advanced Peltier technology, this has been introduced into the market by the company Memmert in 2021. So very important, low energy consumption. That is a very important aspect when we consider the Peltier technology. And we have to think of the ecological aspect. This is in regard to the environment, because when you already could see that there is no coolant. So that means this is a very good system when we consider the ecological aspects, but also the economical aspects. That refers to the costs. So that is a really advanced technology. Let's go further. Let's have a look in regard to the energy consumption. And when we look up for the energy consumption and we consider, for example, an application which is stability testing, for example, according to the ICH guideline Q1A, we have here the long-term tests. Here we have to consider the test is at least 12 months before you can go ahead with the application of your details. So that means we're talking here about long-term tests, and let's look for 25 degrees and 60% RH. And we can see here the different bars, which refers to the kilowatt hours per year. So that means this refers to the energy consumption. And if we are here at a temperature and humidity range of 25 degrees and 60, which is based on the climate zone 1 and 2, for long-term testing, then we have here for compressor device, which is more than 5,000 kilowatt hours per year. If we go further to Peltier devices, you can see the red column, which is already very low in energy. And then have a look to the green line. This refers to our Peltier device, HPP 410 Echo. So that is the advanced Peltier technology. And you can see that here the energy consumption is very low, which means we really can save approximately 90% energy compared to the compressor technology. So for long-term testing, of course, this is a very attractive product also when we talk about this accelerated testing. And this product actually can also fulfill all the climate zones, which are also in regard to the long-term testing when we talk about the climate zone 3 and 4, A and 4B. We have here also made some comparison. And here we have a comparison in this technology, and this is done by an external institute. And the winner in technology comparison of the HPP 750, though here gives information on the Memmert constant climate chamber HPP Echo. Yeah, let's go further. Let's go to the next one. When we talk about Peltier and compressor, then Peltier has also quite some advantages which we have to consider. The one is when we talk about Peltier technology, there is no compressor. So that also means this is space saving. And that means we have a stacking on top of each other. And that means it's more compact since no additional installation space is needed for the refrigeration machine. It is almost vibration free and it has very low noise. This is, for example, also important when we go for application like the protein crystallography. This is which refers to the researches of the atomic structure of protein molecules and thus enables conclusion to be drawn in regard to the mechanism in the human body. Here it is mostly important you have an almost vibration-free unit. Then there is no refrigerant that makes it really very climate friendly. Then there's no more need for a dedicated heat source because Peltier has a big advantage. You can cool down and at the same time you can also heat up, just changing the polarity of the electricity. Then you have the temperature cycles can be run with the same heating cooling unit and it reacts immediately and without cooling medium as everything is electrically operated with extreme high accuracy. And then if we consider this from Memmert, we have here a lot of sizes. So we have size 110, 260, 410, 750, 1060, 1400 and 2200. So that means we have here a wide range for use that we have the different sizes. So improved energy consumption, improved uniformity, improved humidification system, and also humidity system and air routing system. That all has been considered when our R&D department went ahead and introduced the new HPP Echo product. Let's now go further to the compressor technology. Also, this technology is going to be used in laboratory applications. And here we have the cooled incubator ICP and climate chamber ICH. We also have ICP Echo and ICH Echo, and they have a closed system. So here we have an arrangement of the cooling unit and heating in a circulating air jacket, which prevents the occurrence of hot and cold spots, as well as dehumidification of the working space. When we have a look to the graphical on the right side, we can see that heating and cooling is done around the interior chamber. So we have a ring heater on top circulating around. Then we have also cooling, which is done around the interior chamber, which is a compressor technology. And here we have also defrosting cycles, which can be set directly on the unit. That is also important to have always the optimum cooling power on the unit reached. And the target and control dehumidification takes place in the climate chamber, ICH or ICH Echo, also by Peltier technology. That means here, by the Peltier element, we can do the dehumidification on the interior because we create a cold spot. And by creating this cold spot, it means there gets a condensation, and then you can also reduce humidity inside. When we look up now this compressor technology, we have a temperature range from ICP, which is from -12 to 60, or from the climate chamber is -10 up to 60 degrees. And when it works with humidity, there's temperature 10 up to 60, and humidity can be controlled up to 80% RH. So sizes 110 to 60 and 750. Let's have a look more closer to the system, how the heating is done. When we consider the heater, which mentioned is around the chamber in an air jacket, so that means we have on top here a ring heater. And that means by this ring heater, there will be done the heating, large area heating, and around the interior. So that means there's a small blower installed, and this means the air moves around the chamber for the heating up process. It's a very good temperature distribution. The air jacket is around, hermetically sealed, and that prevents cold hot spots, and there's no contact between the media and the heating chamber by this system. So that means also for decontamination purposes, there is no contact between media and heating chamber. And we have an adjustable recirculation fan. Identical conditions for all the samples in the entire interior. And this unit is, for example, going to be used for testing of components in the electronic industry, where we really need to heat up very fast, cool down very fast. This has these big advantages because here precision and reaction time is also very, very important. Let's have a look how the cooling is done. So the cooling is done by also large area cooling around the chamber. So we have here the chamber fan, we have a closed air jacket, and we have the evaporator and the cooling machine on this unit. So that means the cooling is also down around the interior, very good temperature distribution. Also here, no contact between the media and the heating chamber, which is here considered, and is identical conditions for all samples in the interior chamber. And as mentioned, as this unit is more powerful, this is also going to be used, for example, for our ICHL product, or ICHL Echo product. This is the unit which is going to be used for photostability testing. That means here there's an integrated light, UV light and daylight for the testing. So that means here we need more power on the unit, and that's here why this unit comes into effect and is a very good choice. Let's go further. Let's have details on the advantage of this compressor technology. So as mentioned, we use it when we go for photostability testing because higher heat compensation, especially while frequently open the door or additional heat emission comes from the load, unlike the Peltier unit, or especially designed for applications introducing heat into the working space, for example, electronic assemblies or halogen lights. So that means faster cooling down, heating up. This unit is the best choice because this is more powerful. Yeah, let's then go to the next page. So as mentioned, we have these two systems for the technology for cooling down. And of course, both are necessary. So that means you have to consider what are the most important aspects from your side. Are you working permanently at a constant temperatures and a constant climate chamber is a good choice? If you have, for example, to bring in some additional devices in the interior which has a heat emission, then a product with compressor is a very good choice. So is it in regards to low pollution, low sound pollution, noise level, then a Peltier unit comes into consideration. So temperature, humidity, and consistency, this both of units have very good temperature uniformity. And what's about the ambient temperature we have to consider is a very high ambient temperature, and have we to go down very low, then it might be a compressor type. Or if we have constant environmental conditions and we have to cool down less than 20 degrees, then a Peltier unit comes into consideration. And also considering, of course, the servicing part and the maintenance. Here, of course, if we go for compressors, there might be more service requested. Even it must be some experts who do these services when it comes up to coolant. So these are all some consideration you have to consider to look for which product is mostly suitable. For the ICH and ICH Eco unit, please kindly note that we are using here refrigerant, which is called hydrofluorocarbon refrigerant coolant. And this means this has a global warming potential 1,430 over 100 years. Furthermore, we have also a coolant liquid, which is having a GWP of 1, and that is environmental friendly cooling. That is R744. So R744 or 134A. These are the cooling liquids which are used for our products. And also here, our R&D department had done some very good ideas in regard to this cooling based on this CO2 coolant. So this was all in regard to the presentation today. Now, let's go on and let's have also a live demonstration. When we look up to the live demonstration, please kindly let me start first with Peltier technology. We have here one Peltier element that is installed in the rear of the units. And this Peltier element means that we cool down and heat up. So that means there is one side getting cold, the other one warm, and then there is the movement, it's a pump principle, pumping out heat, giving it to the environment that is cooling down in the interior or in the other way around. We have also here a Peltier module. This is used for the dehumidification purposes. So that means here we are just cooling down, have a lower temperature than the interior temperature of the unit, which means we create a cold spot. If there is a cold spot, then there will be condensation, and that means we can dehumidify the interior chamber. Here we can see our HPP Eco product. This is based on the advanced Peltier technology. We can switch on the unit, then we can have a look to this very nice operation controller of the unit. And also let's have a look inside. Here at the rear, we can see our advanced Peltier technology. Next to the advanced Peltier technology, we can see also Peltier for dehumidification purposes. So here we consider mostly important cooling down, heating up by Peltier. For dehumidification, Peltier, but also we have here a system for going up in humidity, which has been improved, and also furthermore for the air routing system, which is also very important for a very good temperature distribution inside. Let's have a look to this controller. On controller, we can set a temperature, then we can set the humidity. So both of these parameters are necessary when we operate with humidity and temperature on a constant climate chamber. Then it's very easy. We just touch the area next to the temperature, we turn around the knob and we can confirm the temperature, and then the temperature is fixed. We can also have here the alarms. In regard to the alarm, we can set a high alarm in temperature and a low alarm in temperature, also in humidity, which is important. And as we also know, that documentation is a very important aspect. The units, they come all with an SD card. The SD card means that there is a storing of all the data, the set data and the actual data. And that means this is done a storage every minute up to 10 years. And then you can connect it. All units have an Ethernet interface or a USB pen drive even, which can be connected. And you can read out the protocol data and have also the protocols, which is requested when you work and you do stability testing, for example. Yeah, this was in regards to our unit with Peltier technology. As mentioned, we have a wide range of sizes. So the Peltier technology is used for cooling down and for heating up. Let's now go further and let's have a look to a cooling machine. Maybe I put this a little bit to the side. So here we have our cooling machine, and we have here the evaporator, which is the cold generator. So that means here we have the gas taking up the heat from the samples from the interior. Then it gets gas goes up, and it means it gives already here for the coolant. And then it goes further to the compressor. So we have here the compressor for compressing the gas. And then further, it goes to the condenser. And then there will also be heat released. And then it goes back by the valve. And then we have here our cycle. That means when we look up this cooling machine, it really takes some space. So that is what you can see. We have here mainly the three components like evaporator, condenser, and also compressor. Let's have a look to the unit itself. That is our ICP unit. On an ICP, we can also switch on the controller type, and we can also have a look to the interior. So here we have heating and cooling around the interior chamber. So it's around from the interior. There is on top, there is a blower, which means by the heat ring, there it will be heated up in the interior, and the cooling is then done also by the cooling machine and by the evaporator, which is on the right side. The compressor you can find here. That's why the unit is also more tall. That is installed here on the lower part of the unit. So that is for the stronger cooling down and faster heating up. That is why we use the compressor type. So both units are going to be used in the laboratory. Yeah, and now we also would like to do a small experiment. Let's go further and let's have a look to this small experiment here. We have here a Peltier element. We use a pipette. Then we put here some liquid that is in regard to colored liquid. Then we have here a generator for the electricity. And now let's start and let's have an electrical circuit. That's why we press the button and let's see what happens. Yeah, it already starts. And this starts to cool down. And let's see what happens when there is the cooling on the unit. Now you see it even has frozen, and now we can see that we have a cooling effect based on this Peltier technology, which has in between the semiconductors. If we change now the polarity for the electrical circuit, So we change this around. And we try our experiment again. You can see it gets fluid and it gets really hot. I don't want to touch this area now. It really will be too hot. Yeah, so as a summarization, we had these two technologies today, Peltier technology, compressor technology. Both technologies are used in laboratories, so it's always depending on the application itself, which system is mostly suitable for your purpose and for your use. So from Memmert, we are using both systems for many, many years. And we have this ICH and ICH Echo type, and we have now HPP Echo, which is a constant climate chamber, which is based on this advanced Peltier technology. If you have further questions, please kindly do not hesitate to contact us. Andreas had been very happy also to help you and support you during this webinar. Thank you again for being with us today. Wishing you a nice day, stay safe and stay healthy, and goodbye from Germany. Bye-bye.